You can title your notes Angle Addition and Angle Bisector. The good news is we've already done this lesson, except it was called segment addition and midpoint. So angle addition is to segment addition as angle bisector is to midpoint. There's an SAT analogy for you. So go ahead and title your notes, and we will, deja vu, we'll teach the same lesson, except now it's in the context of angles. Let's get started. So when we were in the segment addition lesson, we said if 3 points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC. And we kind of dummied it down, part plus part equals whole. We know that if we start here and end here, and then we start where we left off and we end here, that the sum of those segments, the sum of those lengths, will equal the entire segment. We're going to do the same thing, but with angles. So just watch and then I'll let you write it down. So instead of saying, if these points are collinear, instead of saying that, we're going to say, if point B is in the interior of angle AOC, so that's our hypothesis. This postulate will not work if the point is not in the interior of the angle. So if point B lies in the interior of angle AOC, then, okay, let's take this and make a ray out of it. Then the measure of angle AOB, you see that? Angle AOB. So it's saying if I take this angle plus, I better start where I left off and go all the way. The measure of angle BOC equals, so part plus part equals the angle we started with. Oops, sorry, the measure, you need to put M for measure. The measure of angle AOC. Part plus part equals whole, angle style. Okay, I'll give you a minute to write it down. Let's try an example. The measure of angle AOB is 17x. The measure of angle BOC is 7x plus 6. And the measure of angle AOC is 150. Find x. Classic angle addition application. I'll let you try it. It's a good idea to get into the habit of labeling your picture. When we know what the angle equals, you can put that measure inside the angle. You can put the measure inside the angle. And then when there's multiple angles at a spot and I want to show that the whole thing equals a certain degrees, I put that big arc showing it's the whole angle equals 150. So now we have angle addition, part plus part equals whole. Actually, I'm going to take that degree off right there. We combine like terms. Subtract 6. Final answer, all it wanted was x. We'll plug it back in on a later problem. Yay, algebra. Okay, try this one. The measure of angle AOC is x squared minus 5. The measure of angle AOB is 35. And the measure of angle BOC is 6 times x. Find the measure of angle AOC. So we're going to take it one step further this time. Don't just solve for x, find the measure of the angle. Go. This one was in a different order. No, it'll be a whole number. This one, we didn't give you part and then whole. So that's why labeling your picture is so important. You might be given them in a different order. We were given the whole first and then our two parts. We want to do the angle addition postulate, which says 6x plus 35 equals x squared minus 5. we realize that, oh no, worst case scenario, this is a quadratic, and we can't just square root both sides because there's that x, that 6x in there. So this is a factoring problem. There's really no choice but to factor. When you factor, you want your equation to equal 0. So I'm going to move everything to one side. We've got our x squared. If I move this guy over, it becomes negative 6x. And if I move this guy over, it becomes negative 40. So this is what you want to concentrate on factoring right there. You will have two answers. When we factor this, we want numbers, sorry. So we take this 40. We want numbers that multiply to get 40. So we've got 10 and 4. We've got 8 and 5. We've got 20 and 2, ... Okay, we need the pair that we can create a 6 with. We need the pair that we can create a 6 with. So the only pair that can make a 6 is right here, 10 and 4. Now we look at the sign. It's a negative 6. So what I want to do, 10 minus 4, that's 6. Or 4 minus 10, ooh, that's negative 6. So 4 minus 10. You can go back and put a plus sign right there. Then you take each of those parentheses and you set it equal to 0. So 0 equals x plus 4. 0 equals x minus 10. You subtract 4 from both sides. You get x equals negative 4. You add 10 to both sides. You get x equals 10. Now we can finally answer what they asked. Find the measure of AOC. So here we go. We're going to plug x in. 10 squared minus 5. 100 minus 5. 95 degrees. Okay? Now we plug our other solution in. Negative 4 squared. 16 minus 5. 11. So this problem was a quadratic. It had two answers. Shame on geometry if we send you to Algebra 2 and you haven't factored all year long. They would be really mad at us. Making a correction on example 2. Correction. Normally it would have had two answers because it was a quadratic, but it's impossible for the whole angle to equal 11 degrees if one of its parts equals exactly 35. So, unlike Miss Tanton, you need to make sure not only you plug the answers in, but then you go back to your problem and you make sure they make sense. We didn't get a negative angle, which is usually the red flag, but we still got an angle that didn't make sense. All right, the last thing we're covering today is angle bisector. Remember, the great news is we already did this with midpoint. We already did it with midpoint. So an angle bisector is a ray. It's always a ray. It's not a point, it's not a line, it's not a segment, it's a ray that divides an angle into two congruent angles. And we have already constructed angle bisectors. So we've already done this hands-on. We have taken an angle and we have found the ray that divides it into two congruent angles. We use those arcs. We use those arcs to show that the angles really are congruent. Okay, angle addition versus angle bisector. So I just want to look at these three situations, and I don't care about solving for x, but I want to talk strategy each time, because some people were getting confused on segment addition when they were given half of a segment and the whole segment, and they were just putting an equal sign between them, and they didn't understand what they were doing. Yes, Catherine? Okay, so if I see an angle like this, and I see these beautiful arcs, that means that those angles are congruent. When the angles are congruent, you may stick an equal sign between their measures. You may set them equal. Now, in situation number 2, when I see an angle that has been bisected, but they don't give me the two halves, they give me a half and a whole, I have two options. Option number 1, I can double the half, set it equal to the whole thing. I can double 3x. Or, situation 2, I can keep the 3x. I like my 3x, but it certainly doesn't equal 54. It equals 54 divided by 2. So I can double the half, or I can half the whole. This is the same as midpoint, guys. The same thing. Two choices. Choose them because there were arcs on the picture. There were arcs, arc markings. Now this last situation does not have arcs. No arcs. So what we're not going to do is just set those equal because my students do that. 26 equals 3x. No, when there's no arcs, it is not a bisector, So then we go back into part plus part equals whole. I'm not trying to solve these, I'm just trying to show you how you would set each of them up. So if you're given a half and a half, you set them equal. If you're given a half and a whole, you've got those two choices. And then if you don't see arcs, you do not assume that that's an angle bisector. You do angle addition instead. Okay, if you're still in class, try this one. So in this problem, nothing is labeled. You have to pretty much draw your own picture. Ray MO bisects angle LMN. So LMN is our angle. And then this is our angle bisector, MO. Since the problem told us the angle was bisected, we get to add our own arcs. They weren't there, but we add them if it is stated. OMN is 2x plus 14. LMO is 4x minus 2. So we need to ask ourselves what we've been given. Were we given a half and a half? Were we given a half and a whole? Were we just given parts? What were we given? It's easy, yeah. So because we labeled a picture, we realize that this is a half and this is a half. You are allowed to set halves equal to each other because they are equivalent. And then we solve for x. What do you get to? X equals 16. Good. X equals 8. And then we plug it in. Angle LMN. This is the whole thing. Remember, we were given halves, and they want the whole angle. So 4 times 8 minus 2. Oh, that's pretty, right? So this angle comes out to be 30. Making this angle 30, making the whole angle 60. Don't ever trust the picture. The picture is not always drawn to scale. That is bigger than a 60-degree angle. So we don't trust it with our eyes. We trust whatever we solve for x. Okay, last problem. I'm going to go ahead and dive right into it. The problem tells us that ray OB is an angle bisector. When we're told that, we are allowed to add arcs to our picture. BOC is 4x plus 1. And, oh, the whole thing, you must label it correctly. AOC is 98. Now our picture is drawn to scale. This time it is. Here's what we don't do. Don't do this. Don't do this, don't do this, don't do this. So instead, we either need to cut that 98 in half or we need to double the 4x plus 1. It doesn't matter which one you do. I like smaller numbers. Do you like smaller numbers? I like smaller numbers. Now, we're in good shape. So it's 4x plus 1 equals 49. 4x equals 48. X is 12. Oh, and that's all we had to find. Yay! I think I did have one more. I'll make that a warm-up one day. That's a lot of words, huh? Make sure you try your homework tonight. It's part 1 is tonight. There's a worksheet tonight. And then there's more angle addition tomorrow night.